After looking at Lamport's bakery algorithm, let's move to a slightly different problem, that of the readers and writers. In this case, we have multiple entities accessing a shared resource, but such entities are of different types, and we have different safety properties associated with them. Both writers and readers are trying to access a shared resource, for instance, a file. Only one writer at a time can write to such a resource. Multiple readers are allowed to read at the same time, but not concurrently with writers. We are going to look at how we can solve this synchronization problem using semaphores. If we try to visualize the dependencies between the entry and exit sections of writers and readers, it looks like this. For the writer, the entry section needs to wait until no one accesses the shared objects. Once the critical section is over, so the portion in which the writer writes to the shared resource, the exit section can send a signal about the fact that no one is accessing the object anymore, and such a signal can be consumed by both a writer or a reader. For the reader, the entry section should first check if the reader is the first reader of a batch of readers that tries to access the shared resource. If that is the case, then the reader should wait. If other readers are already accessing the resource, then the reader can simply enter its critical section. For the exit section, the reader should of course inform others it is done with its critical section. If the reader was the only one or the last one completing its critical section, then a signal should be sent for writers or for another batch of readers to enter their critical section. Let's now look at the pseudocode that uses semaphores according to these dependencies. We have writers and readers sharing the following variables: 2 binary semaphores, no one accesses, and protect check. Notice that both are initially 1, and RC, reader's counter, which is initially set to 0. The writers simply protect their critical section by waiting on the no one accesses variable, entry section, and sending a signal on the same variable, exit section. The readers use the protect check variable to make sure they consistently update the RC value. In the entry section, the first reader that manages to increase it to 1, so the first reader of a batch, also waits on the no one accesses variable to synchronize with the writers. In the exit section, the reader that sets RC to 0, notice access to RC is also synchronized here using the protect check variable among readers, also signals on the no one accesses variable so that a writer or another batch of readers can then enter the critical section. As before, I suggest you try to have some formal reasoning about how this solution is correct, at least in terms of mutual exclusion and progress. If you think about fairness, you can probably see that here readers are privileged over writers. Once a reader increases RC to 1, other readers can keep accessing their critical section an unbounded number of times. As long as RC is not set back to 0, writers cannot access the shared resource.